So this is the Apex Research Scholar Program, and we're on week 3 already, which is the research design and methodology. So week 3 overview. So number 1, we're going to be choosing a research method. Number 2 will be about variables and controls. And then number 3, we'll talk about ethics in research. And number 4, we're just going to start designing the project. So where you are in the program. So we've done week 1, which is orientation and foundations. We've done week 2, which is the questions and literature review. And now we're on week 3, which is just about the research design. Week 4, we'll go into data and analysis. Week 5, we're going to be writing and talking about communication. And then week 6, we're going to be presenting the research. From question to research plan. A research question tells you what you want to know, but a research design tells you how you will find the answer. Without a design, a question is just curiosity. So, number 1, research question. How does daily screen time correlate with sleep quality in 8th graders? And then number 2, study design. Observational survey. Should be no intervention, and it should measure correlation between reported variables. And then number 3, sample. The target population is 8th graders at one school, and the sample size is 60 to 80 students. And then number 4, data collection. Self-report survey. Daily screen time in hours and Pittsburgh Sleep Quality Index, which is a validated and reputable tool. And then number 5, analysis plan. Calculate Pearson correlation coefficient. Report R value and statistical significance. Well, it's basically just analyze the results. So major research methods. The first is experimental, and it's used in sciences and psychology. So experimental. Researcher assigns participants to conditions, treatment versus control, and measures outcomes. Can establish causation. For example, randomly assign students to 2 sleep schedules and measure memory test scores. And then we have survey and observational, which is used in social sciences and psychology. Gather data by asking questions or observing behavior without intervention. Can establish correlation, not causation. For example, survey 200 students, 200 teenagers on social habits, social media habits, and academic GPA. And then number 3, computational/data analysis. This is used in computer science, math, and data. So analyze existing data sets using code, statistics, or modeling. For example, use US Census data to model correlation between income and school performance across countries. And then we have literature review/theoretical. This is used in humanities and the majority of fields. So synthesize published research to build an argument, identify gaps, or develop new frameworks. No original data collected. For example, review 30 studies to argue that current diabetes screening criteria are outdated. Choosing the right method. Match your method to your question. Don't force a question into a method you find interesting. For example, if your question asks, does X cause Y? Your method should be experimental. And the example is, does sleep deprivation cause lower test scores? If your question asks, is X related to Y? Then your method should be with a survey or a correlational study. For example, is social media used related to self-reported anxiety? And then 3, what patterns exist in data? With that question, your method should be data analysis/computational. What zip codes have highest ER visit rates for asthma? And then, what do people think/experience? With that question, your method should be qualitative. You should conduct interviews or in focus groups. For example, how do first generation students describe college preparation stress? And then, what is already known about X? With that question, your method should be a literature review or a systematic review. For example, what does research say about bilingual education outcomes? Variables and controls. You do not need to run a lab experiment to use these components or these concepts. Every study has variables. So, independent variable, the factor you believe causes or predicts something. In an experiment, this is what you manipulate or compare. For example, daily social media use, hours per day. Control variables. These are factors you hold constant or account for so they don't contaminate your results. For example, age, gender, socioeconomic status, or your school type. And then the dependent variable. This is just the outcome you're measuring, and it changes in response to the independent variable, like self-reported happiness score based on 1 to 10. And then the confounding variable. This is an uncontrolled third factor that could explain your results and invalidate your conclusion. For example, sleep quality affects both phone use and the mood. Sample and population. So, population, every person slash thing your findings could apply to. And then the sample. The sample is the specific group that you actually study. Your sample should represent your population. Sample size. Larger samples reduce the influence of chance. For middle school projects, 30 to 100 participants is realistic, but always justify your sample size. Tip: a study of 12 friends is anecdote, not data. Random sampling. Every member of the population has an equal chance of being selected. This lowers selection bias, and it's hard to achieve perfectly, but it's worth approximating. For, and a tip: a convenience sample, your class, is acceptable if you acknowledge the limitation. Representativeness. Does your sample look like the population? If you study only athletes, findings may not apply to non athletes. Always identify who is excluded from your sample. So be honest in your limitation section about who your sample misses. Validity and reliability. Two qualities that determine whether your research findings can be trusted. Validity. Are you measuring what you intend to measure? Internal validity. Did your study design actually test the relationship you claimed? And external validity. Can your results generalize beyond your sample? And then construct validity. Does your measurement tool actually compare the concept? For example, does your quiz measure comprehension or memorization? And then reliability. Would the same method produce consistent results if repeated? Test and retest reliability. Same participants, same tool, 2 weeks apart. Are results similar? And then iterate reliability. If two researchers code the same data, do they agree? And then internal consistency. Do multiple questions measuring the same thing agree with each other? So, ethics in research. Every researcher at every level has an ethical responsibility to participants, to the field, and to the public. These are not optional rules. So, informed consent. Participants must agree to take part after being told what the study involves. For minors, a parent or guardian must also consent. Confidentiality. Participant data must be protected. Do not share identifiable information. Use anonymized IDs in data records. And do no harm. Study must not expose participants to risk beyond the normal life. Physical, psychological, and social harm must also be considered. And honest reporting. You have to report your findings accurately, including results that contradict your hypothesis. Fabricating or omitting data is research misconduct. So, ethics in action, real cases. So, in 1963, Milgram obedience study. Participants were deceived into believing they were administering electric shocks to others. This caused significant psychological distress. The outcome? It led directly to requirements for debriefing, and limits on deception in research. 1971, Stanford Prison Experiment. Philip Zimbardo assigned students to prisoner or guard roles. Study was halted after 6 days due to psychological harm to participants. And the outcome established that researcher duty of care does not end at consent. Researchers must stop a study if harm occurs. 1979, Belmont Report. Following decades of ethical violations, the U.S. National Commission published principles that still govern all human subjects research today. And the outcome was three core principles: respect for persons, beneficence, and justice. Every research institution follows these, and your project involves human participants, so consent, anonymity, and honest reporting is required. The research proposal, what it includes. Methodology, how you will answer the question, includes study, design, data collection method, sample description, and analysis approach. Background/rationale, 2 to 3 sentences. What is already known from your week 2 literature review and why your question matters. 5. Limitations. What could go wrong? Small sample, self-report bias, time constraints. Every study has limitation. Name yours. And then the timeline. Week by week, plan for completing your project before the week 6 symposium. Example proposal, life sciences. So the topic is sleep duration and immune function in adolescence. The question, is there a correlation between average nightly sleep duration and self-reported illness frequency in 13 to 15-year-olds? The background. The CDC reports 72% of high school students get less than 8 hours of sleep, and it found that adults sleeping less than 6 hours were 4 times more likely to catch a cold than those sleeping over 7 hours. And then the method. Cross-sectional survey. 80 students aged 13 to 15 measure average sleep hours, 7-day recall, and illness frequency past 3 months. Pearson correlation analysis. And then the expected outcome. Students sleeping fewer than 7 hours will report 2 times more illness episodes than those sleeping over 8 hours. Limitations. Self-report bias on sleep duration. No biological markers. Cannot establish causation. Confounds, stress, diet, and physical activity. Example proposal, social sciences. So the topic, public library access and educational attainment across U.S. counties. So the question, do U.S. counties with higher per capita public library spending have higher high school graduation rates, controlling for median household income? The background. Data shows $42 average annual per capita library expenditure nationally, with 4 times the variance across countries. And then the study found library access predicts literacy rates in low-income zip codes. Method, quantitative data analysis. And then multiple regression controlling for income, urbanicity, and demographic variables. Expected outcome, a positive correlation with the variable being over 0.30 between library spending and graduation rates will persist after controlling for income, suggesting library access independently predicts outcomes. And then limitations. Observational design cannot establish causation. County-level data masks within county variation. Unmeasured confounds, like teacher quality or parental education, is likely present. So common research design mistakes. The question is too broad for the method. How does poverty affect children is a PhD dissertation, not a 6-week project. So make it more specific with one outcome, one population, and one context. Confusing correlation with causation. A survey can't prove X causes Y. It can show X and Y are related, so use precise language. associated with, not causes. Measurement tool does not match the question. If your question is about anxiety, don't measure it with a vague question. Use a validated scale like the GAD-7. The sample is too small or too homogeneous. Studying 10 students in your friend group produces findings you can't generalize. So aim for over 30 and document who's excluded. No plan for confounding variables. If you don't account for confounds in your design, reviewers will dismiss your findings. So make sure they're addressed in your limitations section. Mentor breakout sessions, what to expect. After the core session, you will meet with your track mentor in a small group, so come prepared. The mentors will cover track-specific methodology examples, real published studies in your field, common pitfalls in your research area, and they will give feedback on your draft question. What you should bring. Bring your week 2 draft research question, your 3 to 5 annotated sources, at least 2 questions about your design, and a specific idea for your method, and what you will leave with. A refined research question, you'll leave with a chosen method that's appropriate for your track, you'll leave with feedback to build your proposal outline, and you'll leave with mentor comments for revision. So designing for feasibility. The best research design is the most ambitious one that you can actually execute given your time, tools, and access. A completed modest study beats an abandoned ambitious one every time. Do you have access to your participants? Yes. Students at your school, neighbors, family network. Avoid hospital patients, incarcerated individuals, random internet users. Can you collect this data in 3 to 4 weeks? Yes. Online surveys, public data sets, published literature. Avoid multi-month long studies, lab equipment you don't have, and etc. Can you analyze this without advanced software? Yes. Google Sheets, basic statistics, or even coding. Avoid fMRI analysis, genome sequencing, machine learning models, and just avoid those things. So methods by research track. Life sciences. Method, survey, and physiological proxies, sleep trackers, public health data, etc. CS and AI. Method, build classifier or model using open dataset. Run cross-validation. And then math and data. Method, exploratory data analysis, regression, visualization using Python. And then psychology. Method, survey using validated scales like GAD-7, the Rosenberg self-esteem scale, and more. Social sciences. Method, observational or secondary data analysis, policy comparison. And then humanities. The method is comparative textual analysis, primary source, archival review. So week 3, which is deliverable, a research proposal outline. Submit your completed research proposal outline before the start of week 4. So research question should be specific, original, and approved by your mentor, and 1 sentence long. The background, 3 to 5 sentences. What is already known? Why does this question matter? Cite at least 2 of your week 2 sources. And then number 3, method section. Study design, sample description, who, how many people were recruited, data collection tool, and analysis plan. Number 4, expected outcomes / hypothesis. What do you predict you will find? State it as a directional prediction, if possible. Number 6, timeline. Or number 5, limitations. List at least 3 specific limitations of your design. Show that you understand what your study can't prove. And number 6, timeline. Week 4, collect data. Week 5, analyze and write. And week 6, present. Map your tasks to this schedule. So see you all next week. Week 4 will be the data analysis and critical thinking.